Hi there! Today I planned to show you the circuit of the voltage controlled amplifier, or VCA, that is used to change the volume of the theremin output. I proceeded by assembling the circuit on a breadboard first, so I could test its functionality before soldering all the components on the theremin board. However, when I tested the VCA along with the volume variable oscillator and the volume resonant circuit, I got something unexpected. You need to know that I make these videos as I go along with my design, build and testing of the theremin. It is therefore normal that from time to time I find something unexpected that needs some extra thought to make it work. So far, I have been very lucky and everything has always worked as I wanted to. However, this time, the testing led me to think that I should probably give a second thought to the part of the design concerning the volume control of the theremin. There are a couple of important things that I had to revisit. Number one is the calculation of the components of the volume resonant circuit. The calculations rely on the knowledge of the internal capacity of the transistor that is at the core of the volume variable oscillator. Apparently, I didn't use the correct value for that, and so the value of the capacitor for the volume resonant circuit is a little off. Number two is the choice I made to actually control the volume with the hand. I wanted to have a volume that was directly proportional to the level of the signal coming out of the volume resonant circuit. But to do that, I need to make sure that the frequency of the volume variable oscillator equals the resonating frequency of the volume resonant circuit when there is no hand close to the volume antenna. Unfortunately, that is difficult to obtain, since also the body of the person playing the theremin affects the volume oscillator. Under these conditions, it is difficult to have a good tuning of the volume oscillator and the volume resonator. Another option that I have is to make the volume of the theremin inversely proportional to the amplitude of the signal from the volume resonant circuit. This way, I will need to make sure that the frequency of the volume variable oscillator equals the resonating frequency of the volume resonant circuit when the hand is very close to the volume antenna. This condition is much more stable than the previous one, and it is much more easy to achieve when tuning the circuits. This change is also easy to make because it does not affect the circuitry already mounted on the theremin board, it only affects the circuitry of the VCA, which I still have to design and build. So today I am going to show you the right way to measure the internal capacity of the transistor in the volume variable oscillator, and I am going to use its value to correctly calculate the components of the volume resonant circuit. This will cause the capacity in the resonator to change, but that is an easy fix even though the components are already soldered on the theremin board. There is a third issue that I also noticed, but that is only a schematic error since the volume resonant circuit was already assembled correctly. Let's go through all these issues one by one, so that in the next video we can safely move on with a well-thought design. Let's start with the determination of the transistor capacitance. Since I cannot measure the capacitance directly, I had to think about a method that allowed me to measure it indirectly. What I did first was to measure the minimum and maximum frequency that the volume variable oscillator can provide when I move the variable capacitor from its maximum value to the minimum. I called the two frequencies Fmin and Fmax. Once that was done, I did some calculation to find the transistor capacitance. Here is the schematic of the resonating tank of the volume variable oscillator. It is made of four components: the inductor L, the fixed capacitor C, the variable capacitor Cx, and the internal capacitance of the transistor CTR. Given the known values of the lamp components and the measured minimum and maximum frequencies, I can calculate the transistor capacity as follows. From the formula for the frequency of the resonator, I can resolve for the LC product first. And then for the total capacity of the resonator. Then I calculate the total capacity of the resonator for both the mean and max values of the oscillator frequency. The mean frequency gives the max total capacity. The max frequency gives the mean total capacity. The total capacity is given by the parallel of the individual capacities in the resonator tank, which is the sum of all the capacities. From the total capacity, we can calculate the transistor capacitance for both the mean and the max values. And since the mean and max values are different because of the variable capacity, the transistor capacitance should end up being the same in both mean and max cases. Now that we know the transistor capacitance, we know the actual total capacity of the volume variable oscillator capacity. We can use that to determine the capacitor value in the volume resonant circuit. In this circuit we have one inductor L one fixed capacitor C, and a variable capacitor. The value of the fixed capacitor C is basically the one of the total capacity of the oscillator-resonator tank, minus half the value of the variable capacitor, which we will use to fine-tune the resonating frequency. So we finally have the capacity that we need to put in the volume resonance circuit, which is 540 picofarads. So now we can make the necessary adjustments to the schematic of the volume resonance circuit. Here is the old schematic, where you can see the old value of the total capacity, which was 62 plus 470 plus half the 60 picofarad of the variable capacity, or 562 picofarads. You can also see the position of the diode D1 on the right. The diode has to be, of course, on the right side of the capacitor C2, otherwise its rectifying effect will be neutralized by C2 itself. And here is the new schematic, where we can see the new capacitor values and the repositioning of the diode. The fact is, the change in the capacity is really minor, but even so, caused me a lot of trouble when I tried to test my first version of the VCA. Now I should be able to redesign the VCA, making it inversely proportional to the distance of the hand from the antenna, just the opposite as it was before. This change, as we discussed at the beginning of this video, should facilitate the fine-tuning of the frequencies of the volume oscillator and the volume resonator. Hopefully, in the next video on the Theremin, I should be able to show a perfectly functioning circuit. We will know that soon. In the meantime, happy experiments!